The U.S. quickly shut down the James Webb Telescope after it exposed what NASA was hiding on Mercury. This small planet, nestled close to our colossal sun, is anything but ordinary. It dazzles with unexpected treasures, imagined diamonds, scattered across its fiery terrain. But beyond the glitter lies something far more bizarre, an enormous, unusual core that defies all previous scientific predictions. What secrets could these astonishing discoveries be hiding? Stay with us as we dive into revelations that could upend everything we thought we knew about the planets. At first glance, Mercury might seem like just a tiny speck orbiting close to the Sun. But don't let its size fool you. Beneath that scorching exterior lies a trove of phenomenal secrets. Recently, probes from Earth uncovered a staggering find: diamonds sprinkled across Mercury's landscape. Yes, diamonds, on one of the hottest planets in our solar system. And that's just the beginning. Digging deeper, we discover that Mercury's core is exceptionally large and unusual. These revelations raise a burning question. How does Mercury stand apart from its planetary siblings, and what other secrets could it be hiding? The journey to understanding Mercury began with Mariner 10, the first spacecraft to visit the planet. It sent back close-up images of a world full of craters and strange ridges, resembling our moon. The mission revealed Mercury's rough surface, a surprisingly strong magnetic field, and a much larger core than scientists had expected, challenging long-held ideas about the planet's composition. But the most surprising discoveries came later. The Messenger mission, launched 31 years after Mariner 10, revolutionized our knowledge of Mercury. Unlike its predecessor, Messenger was designed to orbit the planet, capturing nearly 200,000 images and providing a long-term, detailed study. It unveiled features never seen before and deepened our understanding of this mysterious world. Among Messenger's most intriguing findings were unexpectedly high levels of calcium and magnesium on Mercury's darker side. This sparked questions about the planet's natural processes. Additionally, Mercury's magnetic field was found to be much stronger in the northern regions, an anomaly compared to other planets. These findings suggested that Mercury's internal structure and development were vastly different from what scientists had previously believed. On Earth, magnetic fields usually form from molten iron moving within the core, but Mercury's unique interior produces a different kind of magnetic activity. Mercury's landscape also stands out due to its extreme environmental conditions. During the day, surface temperatures can soar to 806 degrees Fahrenheit, hot enough to melt lead. At night, they plummet to a frigid minus 292 degrees Fahrenheit. These dramatic temperature swings occur because Mercury's thin atmosphere offers little insulation or heat retention. And the surprises don't stop there. In 2012, Messenger's data revealed signs of ancient volcanic activity, including explosive eruptions, challenging the belief that Mercury was geologically inactive. Then, in 2020, scientists made another jaw-dropping discovery: water ice in Mercury's permanently shadowed polar craters. These regions, untouched by sunlight, remain cold enough to preserve frozen water, even on a planet so close to the Sun. This finding sparked new questions. Could life, similar to microbes found in Earth's harshest environments, exist in Mercury's icy shadows? It opens exciting possibilities about life surviving under extreme planetary conditions. Looking ahead, the Bepi-Colombo mission, launched in 2018 as a joint venture between the European Space Agency and the Japan Aerospace Exploration Agency, is set to arrive at Mercury in 2025. Once there, it will gather detailed information about the planet's surface and geological history. Amazingly, despite its proximity to the Sun, Mercury has a strong magnetic field and even traces of water ice. But here's perhaps the most mind-bending fact of all: Mercury has a day that lasts longer than its year. Unlike most planets, where a day is shorter than a year, Mercury rotates so slowly that one full day takes longer than the time it takes to orbit the Sun. It completes an orbit in just 88 Earth days, yet it takes 176 Earth days for the planet to rotate once on its axis, a true symphony of sun and shadow. Mercury has one of the most unusual day-night cycles in our solar system. While its year, the time it takes to orbit the Sun, is much shorter than ours, one full day on Mercury meaning a complete rotation on its axis takes about 176 Earth days. Incredibly, a year on Mercury is only half as long as a single day. This odd timing creates strange and fascinating effects. If you were standing on Mercury, you'd witness the sun rise and slowly grow larger as it moves across the sky. Then, unexpectedly, the sun would appear to pause, move slightly backward, and continue forward again. This unusual movement is a result of Mercury's extremely slow rotation compared to its fast orbit around the sun. But why does Mercury spin so slowly in the first place? The answer lies in a phenomenon known as tidal locking. Over billions of years, the sun's powerful gravity has gradually slowed Mercury's rotation. However, unlike our moon, which is fully tidally locked to Earth, Mercury is in a unique 3:2 spin orbit resonance, meaning it rotates 3 times on its axis for every 2 orbits around the sun. This dynamic creates extreme environmental conditions, especially given the long durations of daylight and darkness. The side facing the sun experiences intense heat for months, while the opposite side remains in freezing darkness just as long, producing some of the most dramatic temperature swings in the solar system. Adding to Mercury's uniqueness is its extremely thin atmosphere, known as an exosphere. This exosphere is so sparse that it continuously escapes into space, only occasionally replenished by solar wind, radioactive decay, and micrometeorite impacts. In 2020, data from NASA's Messenger spacecraft revealed surprising amounts of water vapor in the exosphere, likely formed when hydrogen from solar wind reacts with oxygen in Mercury's rocky surface. Mercury's rapid orbit and slow spin also have a profound impact on its magnetic field. Despite being small and rotating slowly, Mercury has a surprisingly strong magnetic field, an unexpected discovery that puzzled scientists. This field is likely generated by dynamic movements in Mercury's liquid metallic core, influenced by its unique rotation and orbit. Although weaker than Earth's, this magnetic field still plays a crucial role in shielding the planet from the relentless solar wind, which would otherwise strip away its already fragile exosphere. Mercury's unusual spin and orbit also cause peculiar surface phenomena. There are regions called hot poles, where the sun appears to linger in the sky, making these spots significantly hotter than their surroundings. Conversely, areas near Mercury's poles remain in constant shadow. These perpetually dark craters stay so cold that water ice can survive. Even on a planet so close to the sun, scientists now speculate whether other materials, perhaps even organic compounds, could be hidden within these icy pockets. Studying Mercury presents significant challenges due to its rapid orbit around the sun. Spacecraft must use intricate navigation methods, including gravity-assist flybys of Venus and Mercury, to slow down enough to enter orbit. The Bepi-Colombo mission, launched in 2018 by a collaboration between the European and Japanese space agencies, is currently using a series of flybys to adjust its trajectory. It is expected to begin orbiting Mercury by 2025. Once there, the spacecraft will face the harsh realities of Mercury's extreme temperatures and slow day-night cycle, requiring careful energy and heat management. But navigating Mercury's surface is just one part of the puzzle. Recent studies indicate that the planet might have rotated faster in the past, but slowed over time due to the sun's gravitational pull and possibly past collisions with other celestial bodies. These findings not only deepen our understanding of Mercury's history, but also shed light on planetary evolution across the solar system. As exploration continues, new questions arise about Mercury's fluid-like core, the geological effects of its strange orbit, and what other hidden surprises lie beneath its surface. With each discovery, Mercury proves to be far more than a scorched rock orbiting the sun. It remains a planet full of mystery, challenging our understanding of planetary science and inspiring scientists to uncover more of its secrets. What we know about how planets form and evolve continues to change, especially when it comes to Mercury, a tiny, crater-filled planet that still holds many secrets beneath its surface. Although Mercury is the smallest planet in our solar system, it's packed with mysteries that continue to puzzle scientists. One of the most intriguing features of Mercury is its enormous core. According to Dr. Nancy Chabot, a planetary scientist, Mercury's core makes up about 85% of the planet's volume, in stark contrast to Earth's core, which accounts for only about 15%. This leads to a major question. Why is Mercury's core so large? One leading theory, known as the hit-and-run scenario and proposed by Dr. Eric Asfog, suggests that Mercury might have once been much larger but lost much of its outer layers in a massive collision early in the solar system's history. A giant impact could have stripped away Mercury's outer crust, leaving behind a dense, iron-rich core. But Mercury's surprises don't end there. Despite being small and spinning slowly, it has a magnetic field, a feature unexpected for a planet of its size. Unlike Venus and Mars, which lack global magnetic fields, Mercury's magnetic field is about 1% as strong as Earth's, a discovery made by NASA's Messenger spacecraft that left scientists searching for answers. Even more curious is that Mercury's magnetic field is not centered. Dr. Katherine Johnson and her team found that it's offset by about 20% of the planet's radius, which may be linked to differences in Mercury's crust that affect how heat escapes from its core. In 2020, researchers uncovered even more intriguing data. Mercury's surface contains volatile elements like sulfur, potassium, and sodium, substances that typically evaporate at high temperatures. Their presence on such a hot planet raises new questions. Dr. Patrick Peplowski of Johns Hopkins Applied Physics Laboratory suggested that these elements may have arrived later, delivered by comets or asteroids long after the planet formed. One of the most exciting discoveries on Mercury is the presence of water ice in craters near its poles that are permanently shadowed. These icy areas never receive sunlight, keeping them extremely cold and preserving the ice. Dr. Nancy Chabot was instrumental in this research as well. Even more astonishing is the discovery of dark material mixed with the ice that may contain organic compounds, complex carbon molecules that are similar to those believed to have sparked life on Earth. Could Mercury, with its harsh environment, actually hold clues about the early building blocks of life in our solar system? Mercury also defies previous assumptions about its geology. For years, scientists believed it was geologically inactive. However, messenger data changed that view. Dr. David Rothery from the Open University in the UK identified small, bright depressions on Mercury's surface called hollows, which are believed to be volcanic vents. These features suggest that Mercury may still have ongoing geological processes. Adding to the mystery is the planet's chaotic terrain, a vast, jumbled region of hills and valleys near the South Pole, roughly the size of Texas. First observed by the Mariner 10 mission in the 1970s, this strange landscape may have been shaped by massive quakes caused by changes in Mercury's orbit and the Sun's gravitational pull, according to Dr. Thomas Waters of the Smithsonian Institution. Further insight into Mercury's interior came from Dr. Amir Khan of the University of Zurich. His studies using messenger data suggest that Mercury, like Earth, has a liquid outer core and a solid inner core. However, Mercury's inner core is proportionally much larger, which may be responsible for some of its unique magnetic behavior. These surprising details challenge our understanding of how planets form, evolve, and interact with their environments. As research continues and new missions like BepiColombo approach Mercury, we're reminded that even a small planet close to home can hold big mysteries. From its oversized core and offset magnetic field to its icy shadows and potential organic materials, Mercury keeps reshaping our knowledge of planetary science. The journey into its secrets is far from over, and there's no telling what else might be waiting beneath its scorched, cratered surface. Mercury's inner structure is unlike that of Earth. While Earth has a solid inner core surrounded by a liquid outer core, Mercury is the opposite. It has a mostly liquid core with a solid center. NASA's Messenger mission confirmed this by studying the planet's gravity to uncover details about its internal makeup. Mercury's solid inner core spans about 1,260 miles, 2,000 kilometers, in width, making up nearly half the volume of its entire core, compared to Earth's solid core, which only accounts for about 20%. This difference plays a key role in generating Mercury's magnetic field. Though weaker than Earth's, Mercury's magnetic field is surprisingly strong for such a small planet. Above this large core lies a very thin mantle, only about 260 miles, 420 kilometers, thick, much thinner than Earth's mantle, which is around 1,800 miles, 2,900 kilometers. This thin layer influences how Mercury releases heat and experiences geological activity. In 2012, the MESSENGER mission discovered signs of ancient volcanic activity on Mercury, including shallow depressions known as hollows. These features were likely formed when volatile materials on the surface evaporated, indicating that Mercury had more of these materials than previously believed. Then in 2020, scientists using MESSENGER data identified evidence of a massive magma reservoir that once lay beneath the surface. This ancient sea of molten rock likely shaped both Mercury's outer layers and deep interior, explaining the presence of the vast, smooth plains in the northern hemisphere, known as the Northern Volcanic Plains, which were likely formed by large-scale lava flows early in Mercury's history. But discoveries didn't stop there. In 2022, researchers uncovered even more hidden secrets, including evidence of nitrogen beneath the surface. This nitrogen might be the remains of a once thick atmosphere that was forced underground by the planet's intense heat and continuous bombardment by solar radiation. This raises fascinating questions. Could Mercury's atmosphere have once been much thicker? What might this say about the planet's ancient environment? And could it have supported life in any form? Mercury also hosts water ice in permanently shadowed craters at its poles. Though located close to the Sun, these craters remain in constant darkness, allowing the ice to remain frozen. Some of this ice is believed to be relatively new, likely delivered by comets or asteroids in the last few tens of millions of years. Interestingly, dark patches within these craters also appear to contain organic material, possibly brought by the same impacts. These fragile organic molecules present a rare opportunity to study how such compounds might be distributed in the inner solar system. Further clues about Mercury's geologic past lie in its surface features. Unlike Earth, Mercury doesn't have plate tectonics, but it has clearly shrunk as it cooled over time. This is evident in the many thrust faults, areas where the crust has been pushed up over itself, sometimes rising several kilometers high. These faults suggest the planet's interior has contracted, providing insight into its cooling and structural history. What's more, recent studies suggest that Mercury may still be geologically active. A 2019 study found small valleys, or grabens, near some of the planet's largest faults, features created by crustal stretching. Their youthful appearance implies that the crust may still be shifting. Adding to Mercury's intrigue is its magnetic field, which differs from Earth's. While Earth's magnetic field is powered by molten iron flowing in its outer core, Mercury's magnetic field may originate from a different mechanism. Scientists now believe that it could be generated by liquid metal circulating around the planet's solid inner core, a process similar to magnetic field generation in other planets and even stars. This theory highlights Mercury's complex and surprisingly active interior. There's even more beneath the surface. Researchers suspect the existence of cracks and fissures running under Mercury's crust. These structures might allow heat, and possibly even fluids, to move between different layers of the planet, raising the possibility that Mercury, long considered geologically dead, could still host some internal activity. All these findings remind us that even the smallest planet in our solar system holds massive mysteries, waiting to be uncovered. Even though Mercury's surface appears dry and barren today, some researchers believe there could be pockets of water hidden deep beneath its crust. If such reservoirs exist, they might be remnants from a time when Mercury had a more temperate climate or could be sustained by the planet's internal heat. This concept is similar to findings on moons like Europa and Enceladus, where hidden oceans lie beneath icy surfaces, challenging our understanding of where life might exist in the solar system. The possibility of water on Mercury opens the door to exciting new research into the planet's past environment and its potential to support chemical processes essential for life. Discovering water would not only shed light on Mercury's geological history, but also raise intriguing questions about the interactions happening beneath its surface. Beyond Mercury itself, studying its interior provides valuable insights into the formation of rocky planets like Earth. Understanding Mercury's volcanic activity, internal structure, and ancient atmosphere helps scientists build a clearer picture of how the solar system, including our own planet, evolved. Each new discovery adds to our growing knowledge and offers fresh clues about the early days of the solar system. For example, analyzing trapped gases and materials beneath Mercury's crust could reveal details about its ancient atmosphere and the environmental conditions that existed billions of years ago. Looking ahead, there's increasing excitement about future missions to Mercury. These missions, equipped with advanced technology, aim to explore both the surface and the hidden depths of the planet. With every new mission, scientists hope to unravel more of Mercury's mysteries and better understand its role in the story of our solar system. Despite being the smallest planet and closest to the Sun, Mercury remains a world of hidden surprises. Exploring its depths not only helps us understand Mercury itself, but also offers critical insights into the formation and evolution of planetary systems. Mercury stands as a unique opportunity to study how the Sun influences nearby planets, making it an essential focus in planetary science and space exploration. What new discoveries could challenge our current understanding of the solar system? Stay tuned for more fascinating insights.